Welcome again to a new episode of our chemistry class. And remember, we are still on this topic, the early history of chemistry. So far, we have actually discussed two major objectives. First of all, the objective that had to talk about the idea of the Greeks' contribution to chemical reactions. And we noted there that the Greeks often suggested that the earth or the chemical reactions actually occur because all of matter was made up of four basic elements: earth, air, fire, and water, and that all of these forms of matter are actually made up of tiny indivisible particles that are known as atoms. And then the drawback for that was that these Greeks relied only on their thoughts alone, and couldn't really work out, wasn't really totally accepted, because we know today a lot of science requires proof. You provide proof of whatever hypothesis or whatever thing you found out. The Greeks never gave that to us. Well, time elapsed, and about 2,000 years after, the science of alchemy came up. They call it a pseudoscience. Pseudoscience in the sense that it wasn't really some of the alchemists were fake, in the sense that they were promoting an idea that wasn't really realistic, saying that you could turn cheap metals into gold. Yeah, said you could turn cheap metals into gold. Well, I don't know how that came about, but then we know it's not possible at the moment to turn cheap metals into gold. Other alchemists were quite serious in their business, though, and they came up with the discovery of certain elements, as well as the preparation of mineral acids like we know today. Now that will take us to a very, very important contribution of chemistry, the third objective, if you've been following this class. And that was according to Robert Boyle. Robert Boyle's contribution to chemistry. Now, all of this very, very important, like I said before. But before we talk about Robert Boyle's contribution to chemistry, I'm going to use this opportunity to tell you that the foundations of chemistry, after the advent of alchemy and its demise, yes, let me use that word, demise, the foundations of chemistry were actually laid in the 16th century. So it's important that you take note that the foundations of chemistry were laid in the 16th century. Okay? Very important point to note. Laid in the 16th century. Now, what was it all about? Well, there was a new development. That development was this. It saw a development of what we call systematic metallurgy. So don't worry, don't sweat it. We're just discussing it, remember? We're just taking you down memory lane. You know, you could get manuscripts of these things online. We're just here to talk about it briefly, so that you can have a sense of direction as to subsequent topics we are going to be meeting in chemistry. Okay, so you don't need to sweat it so much. Just know that we are following a timeline here, from the Greeks idea to the alchemist idea, now to the idea of systematic metallurgy, before we go to Robert Boyle. So the foundations of chemistry were laid in the 16th century. It's like you're building a house, of course, you always have a foundation. That foundation was laid with the advent of what we call systematic metallurgy. Among the founders of systematic metallurgy was this man named George Bauer. That name, George Bauer. He lived around 1494 to 1555. George Bauer. He laid that foundation. He was among those that laid the foundation of systematic metallurgy. But let me just give you a brief of what systematic metallurgy is all about. It has to do with the extraction of metals from their ores. Okay, let me break that down as well. We all know what metals are. As science students, we did this in our basic science. Okay, one thing about metals is they usually do not exist on their own. You can't just find them freely around us. Most of the times they are underground, deep under the earth. Okay, so the only way you can extract them is by digging through. Now, when you even dig through the ground, you don't just find the metals freely. You find them as a combination of other metals and other substances. Okay, and those substances are known as ores. So systematic metallurgy actually has to do with the extraction of metals from their ores. You could tell by this time that there were equipments developing, unlike the Greeks who used their head. Okay, and so that was how the foundation of chemistry was laid. Now, another area where the foundation of chemistry was laid was with the medicinal application, talking about medicinal chemistry. And there is one man that is credited for this. Most of the time, we lay our minds to Paracelsus. Well, I would call this name a nickname because it wasn't actually his name. His name was Theophilus Bombastus. Okay, so Paracelsus was also known for his work in medicinal chemistry. That is the medical applications of medicines. Okay, yeah, it's chemistry, and he lived around 1493 to 1548. 1548. That was when Paracelsus lived. So these were the foundations that were laid for us to have a better understanding of chemistry as it is today. But remember our major objective? We are focused on Robert Boyle's contribution to chemistry. So I'm just going to delve into that immediately. Remember, key point, the foundations of chemistry were laid in the 16th century with the advent of systematic metallurgy and medicinal chemistry. And let's quickly move over to Robert Boyle's contribution towards chemistry. And what did Robert Boyle actually do? Note, the first chemist to perform a quantitative experiment, okay, was Robert Boyle. Note that. The first chemist, Robert Boyle was the first chemist, I'll use the word chemist, to perform quantitative, you are quite familiar with that, experiments, was Robert Boyle. Right? Now, quantitative would mean measurements, trying to prove true measurements. We measure most of the time. Even in our homes, we measure. Okay, you have, say, 5 people in the house. You don't just cook a whole bag of rice. 5 people, you measure in terms of what we call derikas in this part of the world where we live. All right, so Robert Boyle was one of the first chemists to perform a quantitative experiment, and he lived around 1627 to 1691. Yes, he is credited as doing that. Now, he carefully measured the relationship between pressure and the volume of air. Air is all around us, right? Yes, we agree that air is all around us. So, his first major experiment was to carefully measure the relationship between pressure and volume of air. That was his first major work. Okay? And after he had experimented and recorded what he found, he came up with a manuscript. He published his first book. And that book is popularly known as The Skeptical Chemists. And he published this in 1661. Robert Boyle's first book. Yes, his first book, The Skeptical Chemists, in 1661. It was when that book was published that the qualitative sciences of physics and chemistry were born. Isn't that interesting, friends? Yes. as at the time when Robert Boyle carefully carried out his quantitative experiments and wrote that book, The Skeptical Alchemist, that was when physics and chemistry were born. So if someone asked you, when was physics and chemistry actually, when did it actually develop? You could say it was around 1661. So we've been studying chemistry and physics right about from 1661. That's quite long, but yeah, so it's quite interesting to see the reasons why we have to discuss this historical analysis so that we can have a sense of direction, like I earlier said. So, apart from the fact that Boyle was the first chemist to perform quantitative experiments, he also had other contributions in the development of and the discoveries of several other elements. Okay, he as well brought up the first definition of an element. Yes, Boyle, interestingly, brought up definition of an element, the one that is actually acceptable today. Yes, Robert Boyle brought that up. Remember, if you open your chemistry textbooks, you're going to see where it is written everywhere that an element is a substance that cannot be broken down into simpler substances by any known chemical means. So, Robert Boyle was simply saying that, look, any substance that cannot be broken down into two or more substances is an element. If the elements can be broken down into two or more substances, then that substance is not an element. And after that time, based on the fact that Robert Boyle tested his experiments, he had proof to show his experiments, that definition of elements was becoming widely accepted, that any substance would be an element if it cannot be broken down into two or more simpler substances, meaning that an element is the simplest substance there is. That definition still holds ground till today. All of this, well, with the discovery of several new elements coming up within Robert Boyle's time, now watered down, now, should I say, buried the idea that the Greeks had. Remember the Greeks' idea of the elements of matter, that matter is made up of only 4 elements: earth, fire, air, and water. Well, Robert Boyle and several other scientists showed otherwise, that there are several elements that matter is made up of. So the Greeks' idea of 4 elements was totally debunked. So that was Robert Boyle's contribution. First, he was the person to perform the quantitative experiment, and he carefully measured the relationship between the pressure and the volume of air, and he also contributed to the discoveries of several other elements, as well as the definition of the elements as we have it today. How very interesting, friends. So far, we've been discussing about the early history of chemistry, okay, and this is going to lay a background for us, a foundation for us to delve forward into chemistry. Please, if you've not subscribed to this video already, or to this channel already, I urge you to do so, especially if you're a science student in SS1, 2, and 3, writing internal exams or external exams, nursing exams, whatever it is. An early history of chemistry, as brief as this, is going to help you understand where you're going to, as far as your study of chemistry is, as far as study of chemistry matters to us at this point in time. So, try and watch this video over and over again. Make your notes. If you have any questions, don't fail to contact me on my WhatsApp page. WhatsApp number is 0903 586 4352. If you have any questions at all, that is my contact. You can always question me and seek answers to this area. Now, the other packages I will bring into you as soon as possible. Weekend special, or weekend cafe like I call it, will be seeing us using past questions, WAEC, JAM, nursing past questions, JUPEB, whatever exams there is within our locality in Nigeria. We're going to be using them, answering the questions there, applying them. It's called the weekend special, and we are coming up with that pretty soon. So guys, if you haven't subscribed, please do so. Like I've always said, you are actually in the right place. Welcome. So our next topic we forward that to you guys. It's going to be discussing the laws of chemical combination, which is actually a sequel to the early history of chemistry. So until then, thank you for staying tuned.